Extended factoring. In this video, we're going to factor three examples of polynomials that require repeated factoring. We're going to factor 2x cubed plus 8x squared minus 18x minus 72. The first step in factoring is to look for a greatest common factor. The last term, 72, is a constant, so we're not going to be able to factor out any x's. But the coefficient of every term, 2, 8, negative 18, negative 72, they're all even, and so they're all divisible by 2. To factor out a 2, I divide each one of them by 2 and write the 2 outside. And now I have x cubed plus 4x squared minus 9x minus 36. When you have four terms, it's a good idea to try factoring by grouping. So I'm going to cut this polynomial in half. And in the first half, I have x cubed and 4x squared, so I'm going to factor out x squared. That leaves me with x plus 4. In the second half, I'm going to factor out, well, I have negative 9 and negative 36. 9 does go into 36, so I factor out negative 9 and I get x plus 4. Well, when I put the two parts together, I have x squared minus 9 times x plus 4. Now, I am not done factoring because I need to recognize that x squared minus 9 is a difference of squares. So the difference of squares factors to the conjugates x plus 3 and x minus 3. And we still have the x plus 4. Now, don't forget that big red 2 that was pulled out in the beginning. So the final factorization is 2 times x plus 3 times x minus 3 times x plus 4. One thing that you can check when you've done a big factoring like this is to make sure the first term is going to work out. So I have an x times an x times an x is going to give me an x cubed, and the 2 outside will give me the 2. So it looks pretty good. Let's try factoring 5x to the 5th minus 405x. The first step is always to look for a greatest common factor, and I see that both terms here are divisible by 5, so I could pull out a 5. And the smallest power of x is x, so I'm going to pull out 5x. When I divide each term by 5x, I have x to the 4th minus 81. There's only two terms. It kind of looks like a difference of squares, but we have x to the 4th instead of x squared. But if I substitute u equal to x squared, then x to the 4th becomes u squared. So now I have u squared minus 81, and I know how to factor that. It's u minus 9 times u plus 9. Well, that's good. But let's go back to x. So u is x squared, so this is x squared minus 9 times x squared plus 9. Well, there's going to be one more step. I can factor x squared minus 9 into x plus 3 times x minus 3. The x squared plus 9 is not factorable. The sum of squares is not factorable. And don't forget the GCF that we pulled out at the beginning. So 5x fifth minus 405x is equal to 5x times x plus 3 times x minus 3 times x squared plus 9. Again, let's check the first term. I have an x squared times an x gives me x third, times another x gives me x fourth, and times another x gives me x fifth. So at least I've got that first term right, and I'm happy with this factorization. Well, here's a doozy. 3x to the 6th minus 15x to the 5th plus 24x to the 3rd minus 120x squared. Let's look for a GCF. Does 3 go into every term? It does. And I also have x in every term, and the smallest power of x is x squared. So I can factor out 3x squared, and when I do, I get x to the 4th minus 5x to the 3rd plus 8x minus 40. Well, now I have a 4-term polynomial, so I'm going to try factoring by grouping. For the first half, I can pull out an x cubed. That's going to leave x minus 5. And for the second part, I can pull out an 8. And that leaves x minus 5. If you have a tendency to forget the GCF, write it at every step so you don't. When I complete the factoring by grouping, I have x cubed plus 8 times x minus 5. And the 3x squared is still in front. Well, now I look at the factors x cubed plus 8 and x minus 5, and I say, hey, I have a sum of cubes. X cubed plus 8 is a sum of cubes. It's the same as x cubed plus 2 cubes, so it factors to x plus 2 times x squared minus 2x plus 4. And 3x squared and x minus 5 are still there. Well, we know the second quadratic in the sum of cubes is not factorable, so that means we're done. So I've rewritten all the factors and put the quadratic at the end. And let's see, I started with a 3x6, so I have an x squared, and another x makes x third, and another x makes x fourth, and then x squared makes x6. Looking good.